Here's a short video about WLED, and I learned about this from Bill over at Dronebot Workshop, and as usual he did a great job explaining the basics of it. So I'm going to show you how I implemented what he did. So WLED is a software that controls addressable LEDs, and you run it on an ESP32 microcontroller. You can connect to it via a web page or a mobile app, and it's got a huge library of presets and effects, different colors, different display patterns for the addressable LEDs, and it even has some features where some of them will react to sound, and I made that version of it that can react to sound. Here's the way the circuit is designed. So it starts with a ESP32WROOM with the USB-C interface that I bought from Sparkfun. It's got a series of addressable LEDs, the WS2812B addressable LEDs, and these things can take a lot of current that can well exceed what the ESP32 can do. So it requires a separate 5-volt power supply. It uses a chip here, basically as a level converter. So the data comes out of the ESP32. I set mine up on GPIO 16, and it comes in here with a 3-volt logic, and then it comes out at a 5-volt logic that goes into the LED strip. And then here's an I2S microphone. It's an INMP441. And so this is the way it's wired up. And then once you get everything wired up, you go into the WLED webpage, and there's some setup you need to do where you tell it which GPIO pins you used for wiring the microphone and the data. So I first built it on a breadboard, and this is what it looks like, and I got it working. I set mine up with an Adafruit Neopixel ring with 16 LEDs on it. I bought this integrated circuit chip on Amazon. Here's the Sparkfun ESP32. I got some leads for the power supply, and then I also bought the microphone on Amazon, and I'll put links in the description of the video where you can get all this stuff. Once I got the prototype working on the breadboard, then I made a more permanent version with a perma proto board. So I put all the components on here and did all the wiring and soldered everything together. It's got a 3.3 volt rail on this side that feeds power to the microphone, and the microphone can only run on 3.3 volts. And then there's a 5-volt rail here that provides the power to the LEDs. And you can see I've got a common ground. There's a ground rail on this side and a ground rail on this side. And then when I built the perma proto board, I had to do some wiring on the bottom of it. So there's a common grounder that connects these two ground rails together. That wire is right here on the underside. One of the wires that goes to the microphone is on the underside. There's a capacitor on the underside. So I did that just to so I didn't have to put everything on the top and manage the space a little better. And then over here on the left, you can see kind of what it looks like. So here's a power supply that I built a couple years ago, and in fact that came, the design for that came from Dronebot Workshop. I designed a case for it, and I put that on Thingiverse, and I'll put a link to that in the description too. This power supply is pretty cool. And then I've got it running with this 16 LED ring now, but I also bought a 8x8 matrix, and in my workshop here I have an LED strip. And again, this is more lights than my microcontroller can handle. So I actually bought a power supply that'll plug into the wall, and it has an adapter here with a screw terminal, and I'll attach that to my LED strip, and I'll do something a little bit bigger. Okay, so in the next segment of the video, I took some video of my my setup running with some music going in the background. For the music, it's a thing I have going in my music studio here. It's just got some drums and bass and a piano keyboard. Okay,